This video discusses cofunctions. Since the sum of the three angles in any triangle is 180 degrees, and angle C is always a right angle equaling 90 degrees, angles A and B must add together to be 90 degrees. Well, since angles A and B are complementary, and we've previously seen that sine of A is equal to cosine of B, the functions sine and cosine are called cofunctions. Tangent and cotangent are also cofunctions. Secant and cosecant are also cofunctions. So we have these 6 cofunction identities. I really try to remember them just all as one. I feel like I can remember what the cofunction pairings are because it's in the name. Sine and cosine, secant and cosecant, tangent and cotangent. So I feel like I know the pairings, and it's just that I can switch from a function to its cofunction as long as I do the complementary angle. And that's what this 90 minus A is saying. It's just saying, oh, complementary angle. So let's practice rewriting a function in terms of its cofunction. We have cotangent of 73 degrees. So the cofunction to cotangent is just tangent. And then we need to also change the angle by finding the complement. And we get 17 degrees. All right, I'm actually going to jump over and do this cosecant first. All right, so cosecant of 25.4, the cofunction for cosecant is secant, and then we need the complement of the angle. So 90 minus 25.4, that's 64.6 degrees. And it's just a rewrite, because sometimes it might be more convenient for us to be written in terms of one function than the other function. All right, let's look at this one in the middle. Here we have like an algebraic expression for our angle, not just a number. So it's going to entail just slightly more work. All right, so for cosine, the cofunction is sine. And for the angle, it's still true that we need the complement. So we're going to do 90 minus what we were given, alpha plus 20. And then we'll simplify this algebraic expression. We'll distribute the negative and combine like terms. We get that we can rewrite cosine of alpha plus 20 degrees as sine of 70 minus alpha. This cofunction identity can help us to solve equations. Now, this is not our go-to technique because it does not find all the solutions to the equation. It will just help us find one solution to the equation. And more times than not, we want all solutions. But let me show you how we can use it to find at least one solution. Because sometimes finding one solution is great because it gets us started on finishing the rest of the problem. All right, so I'm going to rewrite this in terms of the same function. Right. That's going to be a trend later when we're solving equations. We're always going to try to get our equation written in terms of a single trig function. It really doesn't matter if we rewrite it in terms of sine or cosine. I usually rewrite it in terms of the one that has the more complicated argument, whatever is worse in parentheses. So sine looks worse in parentheses. 2 theta is a little bit worse than theta. So I'd rewrite it in terms of sine. So this one's going to stay the same. Sine of 2 theta. And over here, we know we can change cosine to sine, and then we just need the complement, and we always do 90 minus whatever's in the parentheses, so this will be 90 minus theta. Now that we have like one sine equal to one sine, we can set the arguments equal to each other. Now, these trig functions are not one-to-one, but I always think of this as, oh, it kind of reminds me of that one-to-one property for solving log equations, that if we can rewrite it as one log equal to one log, we set the arguments equal to each other. Well, if I can do the same trig function on either side, I can set the arguments equal to each other, but it doesn't give us all solutions, it only gives us one solution. So let's finish this up solving for theta. Adding theta to both sides, we get 90 equals 3 theta, and then we divide, we get theta equal to 30. Let's try one more. We've got our cofunctions, secant and cosecant. We can rewrite it in terms of either one. As I said, I usually pick the function that has the worst looking argument. And I'd say cosecant's a little bit worse, more terms. Well, same number of terms, but coefficients. So let's rewrite it in terms of cosecant. We can rewrite secant as cosecant, as long as we make the argument the complement. So we're going to do 90 minus, and I have to put the parentheses in here because we have more than one term. I didn't in the previous example because it was just theta. So we'll distribute and combine our like terms. This becomes cosecant of 80 minus beta. And we've got cosecant of 2 beta plus 20. Now that we've rewritten it in terms of the same trig function, we can set the arguments equal to each other. 80 minus beta is going to be equal to 2 beta plus 20, and we'll solve for beta. Adding beta to both sides, we get 80 equals 3 beta plus 20. Subtracting 20 from both sides, we get 60 equals 3 beta. And then dividing both sides by 3, we get beta to be equal to 20 degrees. The key thing to remember here is that we can rewrite a function as its cofunction as long as we change the argument to the complement.